Hello class. Today we will be learning about solving multiple angle trigonometric equations. And it's just the same thing that we have been doing here. The only difference is you're going to notice that instead of just x on some of these, you're going to see 2x, maybe 4x. You're multiplying x by some number. But the process is exactly the same. For each of these two problems that we're doing today, we're going to find both the general solutions and we're going to find just the solutions within this interval of one cycle between 0 and 2 pi. Okay, so this problem has already been factored for us. All right, so you can see that it is written as a product of numbers equal to 0. So we have the zero product property that says if two things multiplied together equal 0, then either this equals 0 and this equals 0. And we're going to find the values in each one of those situations that satisfy this equation. All right, so once you have this factored, we will then be able to, I'm going to just draw this little line over here. We're going to be able to solve this problem here. We're going to start this end over here, and then I'll do this one over here. So it's like you have two problems in one. Okay, so for the first one, setting this one equal to 0, whoops, moving around on me here. Setting this one equal to 0, we have the cosine of 2x equals 0. So that one's already been solved for cosine has been isolated. You don't have to do anything other than now ask yourself, what is the value of the angle in which cosine is equal to 0? All right, so I will set up my little coordinate plane here, and you have your quadrantal angles that you're going to be considering. So for this first one, give me a second. All right, this first one over here, you have 0, 1, and this coordinate is 0, -1. So you can see that over here, cosine being the x value, we have cosine of 2x is equal to 0 at both of these positions. Okay, so we can write this out as saying 2x is equal to, you have a pi over 2 for the first one. Now remember, for the general solution, we can kind of kill two birds with one stone, if that's one way we can think about it. So the next solution is a half of a circle away. So we're going to add a half of a revolution to this. Okay, so that would be plus pi over n, where n is any integer, positive or negative. We can go around the circle in either direction, this way or that way, and we can keep going to infinity. And this would represent your general solution for 2x. Okay, now when we are solving equations, we're not solving for 2x, we are solving for x. So your next step would be to divide everything by 2. So in actuality, x equals, I'm going to just divide both of those terms by 2. You get pi over 4 for this one, and pi times n divided by 2 is pi n divided by 2. So this is your general solution that represents every possible value of x that would satisfy this equation. Okay, now the second part of our question is asking us to find the solutions within the interval of 0 and 2 pi. All right, so that half we're going to be solving for. We're looking for between 0 and 2 pi. So now what we're going to do is we're going to evaluate the general expression or equation right here. And what we're going to do is we're going to just simply substitute 0, 1, 2, 3, and all the way until we are outside of this interval. Okay, so the next step would be to substitute n equals 0, 1, 2, until you are outside of the interval. And then that would tell you to stop substituting values of n in when you were outside of that. Now, before I can just start substituting n into here, I'm going to make my life easier by finding a common denominator between these two fractions. So it's super easy to substitute in. So I'm going to rewrite the general equation in terms of the same denominator. And in order to have the same denominator, they both would want to be a 4. So what can I multiply this equation in the bottom by to give me a 4 on the bottom? I'm going to multiply the bottom by 2 and the top by 2. So that would yield plus 2 pi n over 4. So now I'm going to use this equation, and I'm just going to start substituting n into it until I'm outside of the range of 2 pi. So I just make a little note to myself when n equals 0. So I put 0 into here. This goes away, and my first possible solution is pi over 4. When n equals 1, put 1 in for here, and you end up with 2 pi over 4 plus 1 pi over 4 for a grand total of 3 pi over 4. Now put 2 in for n. When n is 2, 2, you get 4 on top, so 4 plus 1, you get 5 pi over 4. When n equals 3, you get 6 on top. 6 plus 1 is 7 pi over 4. And then when n equals 4, you get 8 on top. 8 plus 1 is 9 pi over 4. So I'm going to stop right now. And if you were to write this, let's say as a decimal, 4 would go into here twice with 1 left over. So that's 2 pi plus some, which is outside of your interval of what we are looking for the solutions to be. So that tells me that this is 1 past, it's outside of the interval. So my solutions that are between 0 and 2 pi would stop at n equals 3. And what I have here are my final solutions that satisfy all the solutions for the first half of my equation given here. So now I'm going to do the other half. So that's only part of my answers. So far I have the general solution and I have the values between 0 and 2 pi. All right, so now let's go ahead and do the other half. For the other half over here, let's go ahead and set 2 cosine of x plus 1 equal to 0. 2 cosine of x equals negative 1. And then the cosine of x equals negative 1/2. All right, so let's go back to our coordinate plane here. And we want to know, where is the cosine equal to, first of all, a negative. So if we are looking at a negative, we are looking at the second quadrant and the third quadrant. Cosine, recall, is defined as the adjacent side over the hypotenuse. So the adjacent side is a 1, the hypotenuse is a 2. So what we're interested in is this vertical side here, which is going to be across from your reference angle. So it's always that reference angle that you are in search of, and anything across from the angle across from the square root of 3 is 60 degrees. So there's your reference angle. So when we're doing our general equation, we're going to be looking at what is this value in all revolutions of it in radians, and then we have this one as well. And actually you're getting your the first values that we get are actually the values between 0 and 2 pi. All right, but let's again think about 60 degrees in radians. It's always the opposite of what you think. It's pi over 3. All right, so this value is not pi over 3. In the first quadrant, it's pi over 3. But what is it in the second quadrant if you count your multiples to get you to this location? This is 2 pi over 3 at this location. Okay, and then at this position, you are 160 degree past your half of a circle, and that would be 4 pi over 3, which is the same thing as 4 times 60 degrees, being 240 degrees, if you want to think about it that way. All right, so when we are doing our general solutions, we know that x is equal to, you have your 2 pi over 3, but generally we want every single possible answer. So all the coterminal angles with this one in both directions, you're going to add a revolution, and another revolution to infinity. All right, so that would be plus 2 pi times n. Okay, so that's that first solution. And the next general solution is 4 pi over 3 plus 2 pi times n. And there you have all possible solutions to infinity. That will give you the cosine is equal to a negative 1/2 for that angle. The values between just one cycle, you would have x is equal to 2 pi over 3 and x is equal to 4 pi over 3. Okay, so the solutions for the general solutions for the entire equation, your general solutions would be the 2 in blue that I have boxed out, and then your solutions between the interval of 0 and 2 pi would be those right there. Okay. All right, and there you have it. So there's your first example. All right, and then on the back side, you're going to see we have another one here, just a real basic one. We're going to do the exact same thing. I want you to find the general solution and between the intervals of 0 and 2 pi. Step 1 would be to take this equation and to solve for the secant. All right, so isolate your function. Secant of 4x is equal to 2. All right, so now this is secant. Now we can rewrite this in terms of cosine, so it's easier on the eye. So this is the reciprocal of cosine of 4x. We're going to flip that 2, and we're going to call it, instead of 2, we're going to call it 1 over 2. So we just flip it. And again, cosine is adjacent over your hypotenuse. So I'm going to set up my little quadrants here. This time cosine being positive, you're in the first quadrant and you're in the fourth quadrant over here. The adjacent side is 1, hypotenuse is 2, so that tells me that this is root 3, and that's the one we're in search of. All right, so we have another 60-degree reference angle here. All right, so we have over here pi over 3. And in this quadrant, count your 60-degree angles. You have 1, 2, 3, 4, 5 to get you here. Okay, so there you have this angle and this angle here. Okay, so now we're going to go through and we're going to solve for 4x. So we have what is the angle at which 4x is equal to 1/2. Okay, so you have 4x is equal to, for one solution, pi over 3 plus 1 revolution to get back to that position is 2 pi n. And then the other one, I'll just do it side by side. You have 4x is equal to 5 pi over 3 plus 2 pi n. Okay, but we're not solving for 4x. We want to know what x is. So I'm going to divide everything by 4. And x is equal to pi over 12 plus, now when you take 2 divided by 4, that's 1/2. So this becomes pi n over 2. And we're going to do the same thing here, 5 pi over 12. And dividing this by 4, you get pi times n over 2. So both of these represent the general solution. Okay, so now if that is your general solution here, now let's go ahead and find the solutions between the interval of 0 and 2 pi for just one lap around. And we're going to do the exact same thing that we did in the previous problem. I'm going to go ahead and rewrite both of these with the exact same denominator. All right, and then that will give me over here x is equal to, I want to have a denominator 12, so I'm going to multiply the top and the bottom by 6 for the second fraction. I get pi over 12 plus, when I multiply the top by 6, I get 6 pi times n, all divided by 12. And for this one, 5 pi over 12, multiplying the top and bottom by 6, I get 6 pi n over 12 again. Okay, so these are the two we're going to be using to get these solutions within the interval of 0 and 2 pi. You're going to do the same process. You're going to substitute n equals 0 and keep going until you're outside of your interval. So when n is equal to 0, I'm going to substitute 0 in for this one. So my first solution is pi divided by 12 because the second fraction goes away. When n equals 1, substitute 1 right here, and you get 6 plus 1 is 7 pi over 12. Keep going until we're outside. I don't see us outside yet. All right, substitute a 2 into here. You get 12 plus this 1 is 13 pi over 12. All right, so if I take 13 divided by 12, that's 1 point something. It's still less than 2 pi. So keep going. N equals 3. 6 times 3 is 18 plus 1 is 19 pi over 12. And then let's do n equals 4. All right, that one's still good. 19 divided by 12 is still less than 1. All right, so 4 on top, you get 24 plus 1, and you get 25 pi over 12. Now, wait a minute. When I take 25 divided by 12, I get 2 with the remainder, which tells me right away I am outside of the range. So I am going to only include these for this solution. Okay, and there you have the first set of solutions. And now we're going to move on to the next equation here and do the same thing. Starting all over again, you have when n equals 0, substitute 0 into the first one, and you get 5 pi over 12. Substitute n equals 1, and then you get what? 11 pi over 12. Substitute n equals 2 into the equation. You get 12 plus 5 is 17 pi over 12. And then n equals 3 into the equation. 3 times 6 is 18. 18 plus your 5 is your 23 pi over 12. And I can already see that if I were to do any further than this, I'm going to be beyond. So this is where I'm going to stop. You can go ahead and do it, but you're going to end up with a number bigger than 2 pi for your final solution. So for this equation over here, you have your general form is in blue, and your solutions with 1 lap around, you have 0, for 0 to 2 pi is what you see in red. So that's a wrap on our notes. Go ahead and practice and check your work when you're done. Have a great day.